Hello, I'm Edward Tarte, math teacher. This is another in a series of solution videos to some of my math challenges. This video is for my math challenge entitled Mysterious Triangle Areas. And here's how I presented that challenge in the original video. You have this large triangle. It is not drawn to scale. Three inner line segments split the large triangle into 6 smaller triangles. The numbers are the areas of inner triangles, and the challenge is simply to determine those two missing areas, A and B. Here's my solution. To begin with, I have outlined the large triangle, splitting it into just 2 triangles, outlined in red. If I think of the bases of those 2 red triangles along this side of the large triangle, this being the base of one and this being the base of the other, then the 2 red triangles have the same height, and therefore their areas are proportional to their bases. For example, if one base were twice as long as the other, then that triangle's area would be twice the other's area. Now, there are 2 other triangles that have those same 2 bases, this base and this base, and they are the triangles with areas 70 and 35. Those 2 triangles also have the same height, and therefore their areas are proportional to their bases. Well, we know their areas. They are 70 and 35, and they have the ratio of 2 to 1. And that means that the ratio of the areas of these 2 red triangles must also be 2 to 1. That gives me this equation: 70 plus 56 plus B over 30 plus 35 plus A equals 2 to 1. I cross multiply that proportion and I get 60 plus 70 plus 2A equals 70 plus 56 plus B. Simplifying on both sides, I get 130 plus 2A equals 126 plus B. I subtract B from both sides, and I subtract 130 from both sides, and I get this equation: 2A minus B equals -4. Now I have split the triangles a different way, again shown in red. On the left, you see how I did it a moment ago. That had the base of each of them to be along the right edge of the large triangle. Now in my new configuration, I've got the bases along the left edge, with the bases of the 2 red triangles here and here. They have the same height because each of them has its vertex here, and therefore their areas are proportional to the lengths of their bases. But that is also true of the triangles 30 and A. They have these same 2 bases, and they have the same height because each of them has vertex here where the inner lines cross. So their areas also are proportional to these same 2 bases. That makes the red areas proportional to the areas 30 and A. And from that I get this proportion: 30 plus 35 plus 70 over 56 plus A plus B equals 30 over A. This left-hand numerator is 135, and so when I cross multiply, I get 1,680 plus 30A plus 30B equals 135A. Simplifying that equation gives 105A minus 30B equals 1,680, I divide both sides of that equation by 15 and I get 7a minus 2b equals 112. So I have these two equations with the variables a and b. 2a minus b equals negative 4. 7a minus 2b equals 112. I'm choosing to solve them by substitution, so I take the first equation, add b to both sides, and add 4 to both sides, and that solves it for b. b equals 2a plus 4. Substituting that expression for b into the second equation gives 7a minus 2 times 2a plus 4 equals 112. Distributing the negative 2 and continuing to solve for a, I get a equals 40. And since we have up here that b equals 2a plus 4, I substitute that value of a into that equation and I get b equals 84. So those are the two missing areas in my math challenge mysterious triangle areas. Thank you for watching this solution video.